Hello, this is Christer Sandahl speaking. Now I want to discuss the waterfall process model. It has a bad reputation, but is very convenient if you know how to use it. It is true that the waterfall model symbolizes execution of activities in strict sequence. This means that any activity cannot start before all preceding activities are completed. An example could be the sequence of activities in a chess tournament. A strict sequence can be illustrated by a chain of orange activity symbols, each of these followed by a blue result symbol. Now, let's imagine to execute the symbol activity 1. This activity has full access to use the source input when creating the result 1 output. The activity 1 executes the time period from start to end, and the result will evolve from empty to ready. After activity 1 is completed, imagine to execute activity 2. The behavior will be similar to activity 1, and result 2 will also grow linearly. And finally, when activity 2 is completed, imagine to execute activity 3, again with a linear growth of result 3. Let's conclude execution of a strict sequence of activities. It is simple to understand, and the total duration is the sum of all durations. Because of that, it is said to slow down such processes. Now let's look on the opposite to strict sequence, which is the full concurrency. This means that any activities can be started independently of any other activities being executed. For example, following a wine tasting and judging several aspects of a wine can be done in parallel. Full concurrency can be illustrated by fully parallel orange activity symbols, each followed by a blue result symbol. Let's imagine to execute these activities. Each activity can start and stop anytime and independently from each other. And each created result will grow linearly, independent from each other. Let's conclude the execution of activities in full concurrency. It is simple to understand, and total duration is from first start to last end. It is reputed to speed up a process, but watch out if activities are interdependent. At this point, let's discuss how to calculate the result amount. The simplest and most often seen is to multiply workforce with work period, which ends up in, for example, man-hour, man-weeks, or man-months. However, if the source is not fully available for the activity, then the activity will suffer, and the result will be uncompleted correspondingly. To calculate more realistic, the source availability proportion must also influence and to be multiplied with the result amount. When to calculate result amount over a certain time period, the source availability average for this period is used. Now, let's look on an attempt to speed up a strict sequence. Imagine the strict sequence of activities to be executed as these were in full concurrency. That means imagine to start each activity without bothering about how available their sources are. Firstly, the source is fully available for activity 1 to use, and it will be of no surprise that result 1 will grow linearly without any complication. Also, activity 2 is started at the same time as activity 1. The question is now, how will result 2 grow? Let's try to calculate the amount of result 2 after a quarter of execution. The workforce is 1 unit. Result 1 is the source for activity 2, and the source availability of result 1 can be calculated to 1/8 being the average of result 1 in the first quarter period. result 2 then will end up in as little as 1/30 seconds. Then continue to calculate result 2 for the half, 3/4 and 1 period. See the green curve growing. Result 2 only obtained a half unit at the period end. In order to get result 2 completely ready, imagine to double the activity 2 workforce. Also, activity 3 is started at the same time as activity 2 and 1. It is now a bit trickier to calculate result 3, since its source, result 2, is not linear. But with help of integrals, this is quite manageable. Result 3 only obtained 1/3 at the period end. In order to get result 3 completely ready, imagine to triple the activity 3 workforce. When executing a strict sequence of activities as if these were in full concurrency, the efficiency gets lower the later the activity occurs in the sequence. Activity 2 efficiency drops to 50% and activity 3 to 33%. To try to execute a sequence of activities as they were in full concurrency may seem crazy, but it's quite often seen in reality. Lead time is certainly saved, but at a very high cost, not only in efficiency, but also in quality and morale. Now, try to find a middle way between strict sequence and full concurrency. Imagine to execute the strict sequence in something like half concurrency. See the symbols below. Executing activity 1 gives no longer any surprise, and result 1 grows linearly. After executing half of activity 1, then activity 2 execution will begin. The question is, how will now the result 2 grow? Let's use the result amount formula to calculate the result 2 of the quarter, half, 3/4 and 1 unit of execution. The result 2 is not growing linearly, but the drop in efficiency is not very substantial. Note that result 3 will repeat the growth in the same way as result 2. When executing strict sequence of activities as if they were in half concurrency, it gets a bit of surprise that there is no major drawbacks at all. There will be an insignificant drop in efficiency, but this doesn't accumulate for succeeding activities. The point with this video clip is that a waterfall process does not have to be executed in a rigid and literal way. Execution of a waterfall sequence may be shortened to half concurrency without any significant problems. But be aware, don't shorten the sequence more than so, then significant problems quickly occur. Bye bye, see you in next video clip.